promoting. Uh, some where there's a quiz. I want to practice. Yes. So, I don't know. Oh, it's FV. I mean, it's PHY. Mm, oh, no, it's not. I want them that I can do when trying to like not the ones we do for the YeboPhysics lab tutorials. So physics, specific for physics in general. Okay. Yes. Yeah, it's not clear now.
Okay, no problem. Yes, I do have a question. It's, do you ever listen, do you ever listen to YouTube? Is it only like pre-recorded videos or is it live like this one? Yeah. Um, that's the thing. I can't find any video. I only see like odd videos there. Okay, okay, no problem.
So, will you be able to post this video on YouTube? Oh, so sir. Oh, okay. Okay, thank you, sir. Hello.
I can't see it yet.
Yeah, I see it. Yeah, I see it.
I still can't see it.
It wasn't there a few minutes ago.
Yeah, I can see it too. Yeah, I can see it.
Yeah.
There's still no sound.
So we can hear the sound from other people in Teams. It's only you that we can't hear. Yeah, we can hear the sound from other people who are talking on Teams. Also, I'm saying when someone speaks on Teams, we can hear them on the YouTube channel, but we can't hear you on the YouTube channel. Yeah.
I say I can't hear you.
Okay, can you guys hear me now on YouTube? I am now plugged in my Razer mic. The guys on YouTube, can you hear me now? We can start with these problems.
Yes, sir, we can hear you.
Okay, thank you. Great, now we can start. And I know that a lot of you guys have.
Yes, we can
Yes, sir.
hear you, sir.
Great. Okay, now you can choose which one you want to do, YouTube
Some of
or.
us we can't hear, sir.
Okay, I think that is then
But now you
Yeah,
your.
we
can
can
follow
hear him
on Teams.
on YouTube, sir.
We
Okay,
can
great.
hear
I still can't
you.
hear you, sir.
Me, I can't. Me, I can't.
I can hear other people, but
Mm.
not you, sir.
I say I can't hear.
I can hear you on YouTube, but not on Teams.
Okay, then some of you can
So
hear
I
me,
can
some of.
hear you. But I know continue to speak.
Okay. Oh, by the way, if you have both of them open, it's only going to register one of them. Guys, while I'm speaking, it's only going to play one of me. It's not going to play both the YouTube and the thing and Teams. If you can hear me and on at least one of them, then that's good. Okay? Then you choose. This is why I say you choose which one you want to do. Right? Pick one of them, which one you want to follow me on, either on YouTube or on Teams. Okay? Primarily, we usually use YouTube, but uh, we've also incorporated Teams for those of you guys that actually prefer Teams. Okay, so there is in the chat something here. Let me just check there. But I'm going to start working on these problems now. Is there someone who can't hear me on both of them? Now you can't hear me on Teams. And one of you have your mics on. Okay. Uh, I'm going to switch off. No, I'm not going to switch off either of them. Okay. Can I, by a show of hands, is there one person that can't hear me on either YouTube or Teams? Okay. Can you hear me on at least one of them? You should be able to hear me clearly on YouTube now. Okay. Ms. Guya, you indicated that you can't hear me on both of them. I have no idea what is wrong. But since other people are getting me, it seems that it must be something on your device.
Sorry, that was a mistake.
Okay, cool. Anyway, guys, I'm going to go ahead to what this is. Okay. Now, just a quick recap on what you've done so far and things I think. And by the way, guys, everyone that is going to be your demi has done. Has Dr. Jenna has his PhD in physics. Arnold did his masters, finished his masters, and I am currently, and he's about to do his PhD, I think, and I'm also doing my PhD in physics. So, and now my camera is just knocked off. So, we know a little bit about how to study and what to study and what you should focus on, because we've been doing this since for the last 3 4 years. We've been tutoring students, preparing them for the exams. Okay, now if you have any questions at any point, like I usually say, just go ahead and ask. Okay, so question one. Okay, I'm going to try and write big and legibly so that you guys can see. If you have any questions, at least, guys, if you can hear me at least, then that's good. Okay, if you can hear me, let me refresh, maybe that's that. If you can hear me on one of these platforms, then that's great. The problem, and I just, there you go. Now I want you to know that if you might be going home later on and seeing multiple videos, I'm going to pick the correct one. So, starting with problem number one. Let's just, before I start with problem number one, this is what you need to know. A recap. A quick recap. And guys, I have a horrendous handwriting. Okay? Why never. That's why I studied math. Symbols are not as difficult to make. Okay. So, a recap. The fundamental SI units that you need to know. Okay, the fundamental SI units that you need to know. The fundamental SI units. Okay, that you need to know. You need to know these because you're going to be doing it or using them for the rest of your physics or engineering degrees. The unit of length, of course, is the meter, denoted by an M. Uh, the Teams meeting ID. Let me just send it to you. Where's my email now? I assume that's your actual name. Let me try to find my email now. I'll send it to you via email. And I've closed mine for some reason. Uh, can you just go to your emails? Earlier on, I sent you an email, Teams invite. Just click on the invite and join the meeting from there. That's the easiest. Mr. or Miss Setloboko, unfortunately, YouTube does not give me a Miss or Mrs. or Mr. or whatever. It just gives me your names. So can you just join? If it doesn't work, then let me know and I'll access my emails and send you another one. Otherwise, for mass, and if I'm writing too small, I know. I'm trying to write as big as I can. For mass, we have the kilogram, of course. And I know you know this from high school physics, but it is important that I emphasize it, okay? Time is in seconds.
I see you message. That's a lot.
I see some ladies are having fun. Time is in seconds. And then, of course, the final one that you are most likely going to come across is charge. These are the fundamental SI units. The rest of them you, you can denote using these fundamental SI units. We call them derived units. Okay, for instance, speed is a derived unit of meters per second. Okay, so charge we have the coulomb, and it's denoted by a capital C. The rest we have derived units. Okay, now let's continue. The second thing you need to know, and that's going to help you a lot, is prefixes. Okay, metric prefixes. The fundamental units recap: length, meter, mass in kilogram, time in seconds, charge in coulomb. For your entire engineering and physics degree, those are going to be your fundamental units. The rest of them can be derived from those units. Uh, Azola says some of you guys didn't get a meeting invite on Teams. You should have gotten an email. If you haven't gotten an email, it means you are not registered at the moment. I'll try to fix that. Uh, if you can at least follow on YouTube, just follow it for now. Uh, and I'll try to sort out the email problem because I sent everyone a Teams meeting invite. If you got my email earlier on, if you got an email from me earlier on, then you should have gotten the Teams invite as well. You just join the meeting from there. And I know I may have missed some of you guys. Well, not missed. I sent out, but no email. You're registered, but no email. Okay, Kelvin. Let me see. Those of you guys, I'm going to send a quick email quickly. Just want a Teams invite, right?
We can't hear you, sir.
You can't hear me on which one? On which platform? Okay, so Azola, those of you who has not received the Teams an email from me today, can you just drop your names there at the bottom in the YouTube chat? Just let me know there. Because for some reason, remember, I don't send it individually, I send it to the whole group. So if you have not received an email from me, just drop it in the group on YouTube and I will send you a link. Guys, you need to check your student emails. If you have not received an email from me today, please drop your name. I mean your real name, the name you registered at the university for, because that's the name that's going to pop up when I search for your. Okay. I can't go on your YouTube names because there are a lot of names there that I am highly sure that is not your actual name. If you want me to send you an Teams invite right now, like at this exact moment, please write me your name in the comment section. Okay. Okay, I have one. Morokane. Pilakazi. That's you. Okay. This might take a while. Okay, guys, if you want to join the Teams meeting, you don't have to, okay, because it's going to take me a while now to get. Oh, some of you guys just invite some of these people in Teams, please. I'm going to send out everyone an email now. It should take me a little bit of time, well, a few minutes. Sabelo. Guys, I have no idea what's going on with PHYV, but I'm going to do this thing. If you are registered, I'm not going to send you individually. If you are registered, then you should receive this invite right now. FVV. If you are registered, then you should receive my next email. Okay? I am just sending you a link to everyone now. Those of you who already have the link, please ignore it. Waiting it for. Okay, guys, you can stop sending me your names. I'm just going to send it to everyone again. If your name is unfortunately not on this email list, then I do not know who you need to talk to, because I'm sending it to everyone that is actually registered now. If you don't get my next email, then I do not know, guys. Okay. I just sent an email to both PHYV 101 registered students and FVV 101 registered students. Okay. Guys, you can stop writing your names now. I just sent in the email now. It's going to take me years to individually send you those things, so I'll send it to everyone. If you don't receive my next email, then it does you don't show up on the registered email list, and unfortunately I do not know what to do when that happens, because I send out everything through the registered email list. Okay, you should receive an email with a link in the moment. But I'm going to continue. Okay, metric prefixes. Metric prefixes. Okay, we've done the standard fundamental units. Now we're going to do metric prefixes. Okay, and this is something that a lot of students should know by now, but they still get wrong during exams and stuff. So a metric prefix is like the following: centi, and centi is 10 to the minus 2, and it's denoted by a C. Okay. The next we have milli, which is denoted by 10 to the negative 3, and it's denoted by an M. Then we have after milli micro. Micro is 10 to the negative 6, and is denoted by this symbol mu. Then we have nano, which is 10 to the negative 9, and is denoted by an N. And lastly we have pico, which is denoted by 10 to the 12 and a P. Okay, those are the metric prefixes, and then the other three you need to know with positive exponents is kilo, which is 10 to the 3, and is denoted by a K. We have mega, which is 10 to the 6 and is a capital M. And lastly, we have giga, as in gigahertz, 10 to the 9 and is denoted by a capital G. Okay, that is the metric prefixes that you need to know for your physics degree. Okay, you need to know all of them. Now I'm going to go to our problems. Okay, are there any questions? Okay, guys, any questions regarding fundamental units and metric prefixes? Okay, this is just a quick recap. You should have done this last week. Is there any questions regarding fundamental SI units and metric prefixes? Anything that comes to mind when you think of those things? Anything that comes to mind, guys? I sent out the emails again right now to the entire lists. Uh, I have no idea, but I will try to figure out what is happening, why some of you are not receiving emails, because I'm sending out a blanket email to everyone registered in the group. Okay, maybe ICT have not put you on the group yet or whatever. Okay, Chibbles number one, that is your YouTube handle. Uh, I assume you are answering my question saying regarding the, the question I just asked about everyone receiving my email. Is that the question you're answering when you said no?
Problem with sound.
Sorry, you can speak? Guys, is there any questions regarding fundamental units and metric prefixes? Guys, as long as you can just hear me on YouTube for now, we'll try to get to the bottom of this email list problem. Because I sent an email to everyone that is currently registered in this course. Okay. Oh yeah, you should know these prefixes. Wanda M just asked if they should know these prefixes by heart. Yes, you should. You should know them off the top of your head. Don't worry. Don't go and memorize them, which is good. You should be able to memorize them. But with time, it's just gonna come. Okay, Azola, I'm going to try and look into that thing about, because I sent the exact same email that you see, that thing that Prof. Wolifir would use, or Dr. Wasa would use to send an email to you. I do the exact same thing. I sent to PHYV, I sent to FVV, the entire group. Okay, I'm going to, man, Mr. Cello Kelvin, I assume it's a Mr. Uh, I'm going to try and find out why some of you are getting my emails and some of you are not getting my emails, because I send it to entire group. Is it the YouTube quality that's bad? If it's the YouTube quality that's bad, it means your reception there is a bit dicey, and of course it's windy here. It's PE. I am at my optimized levels for my picture clarity and stuff. I will tweak it again. Okay, some people, you see, that's the thing. If your data or Wi-Fi is not picking up the signal that good, I will be looking very fuzzy. Some people are seeing good video. Okay, life with Sisipo. I gather that a lot of you have not seen my email, but as long as you can follow me on YouTube for now, guys, this email thing, I will try to speak to whoever is in charge here about emails and stuff. And unit vectors in an equation, okay, you will most likely never have to use unit vectors in equations, okay, because it's impossible. Equations are designed to handle just numerical values. Okay, let's continue. So no one has any problem. So you're going to have to know these fundamental SI units, and you're going to have to know these metric prefixes off by heart. Okay, you're going to have to know them off by heart. Now, first problem that we have been avoiding, let's say that. Okay, it says the standard kilogram is a platinum iridium. Why do I have to bump this thing all the time? It's a platinum iridium cylinder. Okay, that is the standard. Remember, we can't just say this thing is a kilogram and then everyone has different kilograms. But in the Institute of Weights and Measures in France, there is a platinum iridium cylinder, okay, and it has a height of 39.0 millimeters, and it has a diameter of 39.0 millimeters, and this platinum iridium bar is what we use to compare everything else to. Okay, it's the calibration standard. It is the standard kilogram. Okay, it's this thing's weight that determines that what we know as a kilogram. Okay, so it's this bar, this kilogram, this platinum iridium bar. Okay, the reason why they chose platinum iridium is because it doesn't deform or lose mass over time. It's not, it's a very stable alloy. Okay, so it doesn't lose its mass over time, because let's say in 10 years we now have to redefine the kilogram because this bar has rusted. Okay, so can someone just invite, let me just do it myself. Let's see if there's anyone. Most people the have left the Teams meeting. Okay, if you can just follow me on YouTube for now. Okay, it's going to be the primary instruction anyway. Teams is there to help with speaking and stuff. But if you can hear me on YouTube for now, just follow me on YouTube. I'm going to fix the problem with the emails and stuff. Okay, so we have this in France. There is this bar. Okay, it's made of platinum and iridium. Okay, and someone, don't ask me why they picked this particular bar or why they cut it in this length and diameter, but they just decided that this is going to be the weight of a kilogram. Okay, and everything else is going to be compared to this weight. So this is what the standard kilogram is. Okay, the standard kilogram is a platinum iridium cylinder that's 39 millimeters in height. It's a cylinder, so it's 39 millimeters in height. Let me see. And we have this cylinder. It's made from platinum and iridium. That is not important. What is important is its measurements. Okay, it has a diameter of 39.0 millimeters, and it has a height of 39.0 millimeters. Okay, now they are asking us, what is the density of this material? Okay, can anyone please tell me, how do you work out density? Can someone still remember how you work out density? The answer's already there, by the way. Okay, what I want you to understand is how to get to that answer. Can someone tell me, how do you work out density? Keith Rez, the quality is bad because of your either your Wi-Fi or your data, or the signal is that is influencing the signal where you're at.
It's density is equals to the
Latita, you've already answered. Okay.
Like
Uh,
density, don't you like
Go ahead. Density, I seem to have lost you. Density is mass
density
over
is
volume.
mass divided by the volume.
Yes, that's good. Okay, now, usually we don't denote density with a D, we denote density by this symbol, rho. Okay, rho is density. It is mass divided by,
Density is equals to mass divided by the volume.
yes, thank you. So, rho or density is mass over
Let's
volume.
divide by volume.
Okay, guys, thank you. For those of you who got it right, thank you. So now we have mass divided by volume. Okay, so they want the density of this material, but we are given its dimensions. Okay, now if we have the dimensions, we can actually work out the volume. Okay, so let's work out the volume. What's the volume of a cylinder? Okay, it is the area of the base, the area of the base multiplied by its height. Okay, now the area of the base, a cylinder has a circular. Okay, someone says there's a serious lag. That is due to your reception. Okay, Aaron, Aaron G. Uh, the lag is due to your reception. I'm sorry. Next time I'm going to try to get everyone a Teams invite so you can actually hear me in Teams but watch me in YouTube. That usually works best. You would switch off the YouTube audio and then listen to me in Teams because it's instantaneously, and then watch me do the problems in YouTube. Okay, so the volume of this cylinder is going to be area of the base multiplied by the height. Now the area of the base, okay, it's a cylindrical shape. So the base is a circle. Okay, now the area of a circle is pi r squared. Okay, pi r squared, and then multiplied by the height. Okay, that would be the volume of a cylinder. Okay, so it's pi multiplied by the radius squared. Now how do we get the radius? Okay, we have at the moment the diameter. Now the radius is just the diameter divided by 2. That's the radius. Okay, and we need to square that. Okay, that is in meters. That is the radius in meters. It's 39.0 squared. 39.0 over 2 squared. That's the radius multiplied by the height. Okay, sorry, this is in millimeters, and then this should be in millimeters. 39.0 millimeters. That is a double M there, sorry. So now we have
We
the
get it
volume.
from the diameter.
Okay, uh, so the lag is due to both signal that's not being, the quality, and the lag is due to the signal at your end. So given this, volume should be, if you work it out, okay, now I already converted everything to meters. Okay, so I converted everything to meters, but I'm going to work in millimeters now. Let's see. Okay, because I want to show you how to do dimensional analysis. Okay, how to convert from meters to millimeters and stuff. So let's see. We have 39 over 2. That is 0.01. That should be 19.5. 19.5 squared. What is 19.5 squared? Let's see. Let me just put my calculator a bit up. 19.5 squared is 380.25 times pi not pi squared, just pi, multiplied by the height which in this case is 39.0, and that should give you 2000. If you have a different answer, please let me know. Remember, I also make mistakes. 1/8 millimeters, but it's not going to be millimeters cube. Now let's continue. We have, just check if I did it correctly. No, I did not square. I did not square my 95. That's the reason. I removed the square here. Should be there. There it is. Yep, there it is. Sorry. Just make sure you square. So the answer is 4, 6, 5, 8, 9.03 cubic millimeters. Okay. If you got this, can you just give me an indication if one of you. Oh yeah, thank you there, live with Sisipo. You reminded me I didn't square there. Right. Now we have the volume in cubic millimeters, okay? But we don't want to work in cubic millimeters because the answer is given in kilograms per cubic meters. Now, how do we go from cubic millimeters to cubic meters? Now, this is very important, okay? This is where what is known as dimensional analysis comes in. And I used to be, I tutor FVVs face to face, and quite a lot of them didn't know how you would go, say, from cubic millimeters to cubic meters. Okay, this is this you should really pay attention to this part. Now this is why this problem was picked, because of this dimensional analysis part here. Okay, this is what we have. Okay, we are now converting from cubic millimeters and we want to go to cubic meters, the volume. Okay, so what we do is we take the value that we have in cubic millimeters, okay, we multiply it by, okay, we multiply it by, remember this is in millimeters, we want the answer in meters. Okay, now you're always going to multiply by a fraction. Okay, you're always going to multiply by some fraction. Okay, now what comes on top is the units that you want. We want the units in meters. Okay, we want it in meters. Okay, and what you have here in millimeters is going to come at the bottom. Okay, so we want it in meters. Whatever value you want comes at the top, and whatever you want to get rid of comes at the bottom. Okay, you're going to be cancelling out these. Okay, you're going to see how now. Okay, so you want meters, so meters is going to be on top of the Chantel Ramutla. Okay, thanks for reminding me. I forgot to square. See, that bit of a lag comes in now. You probably typed it the minute I did it. So, 1 meter is equal to how many millimeters? This is the important part, guys. You see this part here. This part here is what is known as your conversion factor. Okay, you don't, if you know this, you never have to remind to say divide by 10,000 to get to that and that. All you have to do is just do this. Remember that what comes on top Can the person please switch off their mic? Okay. Someone, you have your mic on and it's kind of disturbing. Okay. Thank you, Laticha. Uh, Let me just check this mic is on. Okay, guys. Okay, this part here is very, very important. It's called dimensional analysis. Guys, please switch off your mics. It's kind of disturbing. So, whatever you want, okay, the unit that you want should be on top, and the unit that you don't want, which is this unit here, which you want to get rid of, should be on the bottom, okay, millimeters. Okay, then how is meters correlated to millimeters? Okay, there's 1 meter for every 1,000 millimeters. Okay, that's the conversion factor. You need to unfortunately know the conversion factor between, say, meters and millimeters, or pounds and kilograms and stuff like that. But usually, if it's not something like this, something easy as this, they will give you the conversion. Okay, now if this is remember, we are not working in meters. Okay, so you need to cube both of them. Okay, because if you cube both of them, then you need to cube the conversion factor, because you want to get rid of millimeters cubed and you want meters cubed. Okay, so this is going to be 1, and if you cube this one, it's going to be 9,000, just nano, so it's going to be 9, so it's going to be 4.6, or just 4.658, 9. I know a lot of you did it right now, times 10 to the 1, 2, 3, 4, -5. That's it, right? It should be -5 cubic meters. Okay, I know a lot of you did it quickly and you got to 46.59 or 46.589, whatever, but you forgot the most important part, this cube here. Okay, this cube. Okay, because we are not getting rid of a meter, we're getting rid of, we don't want meters, we want meters cubed. And we're not getting rid of millimeters, we want getting rid of millimeters cubed. Does that make sense? This is how you do dimensional analysis when there is not roots, uh, to the power of exponentials involved. Okay, the two guys, the two Mr. Cello and William, I saw what you did, and I'm hoping that you guys understand now why I got 10 to the -5 after my values. Okay, because you need to cube this part in order to get rid of millimeters cubed. Okay, you need to cube the whole conversion factor in order to get rid of, oh, Miss Erin G, I assume it's, since Erin is a girl name, I assume. Okay, thanks. It's cool if you understand. If there's anyone that doesn't understand, just let me know in the comments section. I'm just going to wait like for 10 seconds. If you don't understand, let me know. If you do understand, then brilliant. Then we can continue. So we now have a volume. We have a volume. Speak. I just hear someone mic off. So as soon as your mic comes on, I assume that you want to ask something or speak. So this is the volume that we have now. 4658903. I'm hearing myself. This is the volume that we have now. Okay. Okay, God candidate, you say you're lost. Okay. Let me just recap quickly. Okay. Now, let's say you have millimeters cube here. Okay. You have millimeters cubed. Okay, now you want this answer in meters cubed, correct? You want it in meters cubed. So what you do is you multiply by some conversion factor, and the conversion factor is going to be yes, I can change the quality on the settings, but this is just the average quantity. I'm talking about those of you who are really not seeing the good quality. I can change the pixel size only, but it's still going to be better if you have a bad signal. For those of you, let me just get this finished here. Those of you who don't understand what happened here, I want to get rid of millimeters cube and I want meters cube. Okay, so in order to get rid of millimeters cube, okay, I need to multiply by some conversion factor. Now this conversion factor, oh, jutsu, thanks for clarifying. uh, Now to get rid of this millimeters cube, okay, ignore the cube for now. It's going to come in, just ignore it for now. So you want to get rid of, don't ignore it in the problem, but just ignore it for now. During the conversion, remember, you're going to multiply by some conversion factor. Okay, so what you do is you just look at, ignore the cubed part for a bit. You multiply by some fraction. Okay, now whatever comes on top of this fraction is the unit that you want. You want meters, so you're going to write meters on top. And you want to get rid of millimeters, you're going to write millimeters at the bottom. Okay, I'm going to do another conversion problem quickly after this one. So you write millimeters at the bottom. Okay, now 1 meter, now you need to get a conversion factor. Okay, that is 1 meter is equal to 1,000 millimeters. Okay, 1,000 millimeters. Okay, as long as you get this part correct. Okay, so 1 meter is equal to 1,000 you need to get some conversion here. So 2 meters will be equal to 2,000 millimeters. Doesn't matter, I just picked the easiest one. Okay, but remember, you are not just working with millimeters, you're working with millimeters cube. So you just cube the whole conversion. Okay, you cube the whole conversion, and if you plug it in to your calculator as it is here, you will be able to get this answer. Okay, those people that says that they are lost, does it make God candidate and Yolanda Tozake, does it make a little bit sense now? I'm going to do another problem now quickly on conversions. The reason why I'm hammering on conversions is because you're going to be doing. Yes, life with Sisipo, I did divide by 1,000 cubed. Okay, you can say here, when you do this, you can say 1 divided by 1,000 and cube the whole thing, or you can say 1 cubed divided by 1,000 cubed. That's what happened. Does that make sense? Those guys that. Okay, Panashe, you asked if it's Panasha asked if it's okay if you convert everything before you do the actual calculations. That is okay, but usually, sometimes you're not going to be able to. They're going to give you an answer, say in grams per cubic millimeters. Okay, then you're going to have to know how to work with this. Okay, so the reason why I did it originally the same way. I converted it first to meters and then I did it. That's perfectly fine. But sometimes you're not going to be given the choice to convert to meters first. You're just going to be given it in kilograms per cubic millimeters. Now you have to convert it to kilograms per cubic meters. You're going to have to know how to do it. Okay? This is the point of this exercise. It's not actually to see if you can work out volume, density. That is easy. Everyone knows that you can work out density. The point of this exercise is to know if you can convert from millimeters cubed to meters cubed. If you know that, then you got the answer to this question. I'm going to give you another thing now. Now let's just finish this question. We have the volume now. The answer was for the question was for the density. So rho, meaning density, is equal to mass over volume. Okay. Now the mass is 1 kilogram. Okay. The mass is 1 kilogram. It's the standard kilogram. And its volume is 6.58903. Another important thing is significant fingers, but I'm not going to be dealing it with here. I'm just dealing with dimensional analysis mostly. Okay. And then if you divide that, 1 divided by that whole problem should give you, oh, did I write something wrong here? It should be 4, not 6. It should be 4. Sorry. It should be 4.5. 4.65. I wrote from the wrong problem. Sorry. It should be volume should be 4.65 4.65 8903 times 10 to the negative 5 cubic meters. Okay, now it's 1 kilogram divided by 4.65 658,903 times 10 to the negative 5. I hope you are okay. It sounds like you fell or something happened. And this is going to give you an answer of 2.15 times 10 to the 4 kilograms, which is on top, kilograms per cubic meters. And this is exactly the answer that we should get, 2.15 times 10 to the 4 kilograms per cubic meters. Okay, someone asked, I'm going to make another problem similar to this one right now, but it's not going to involve this type of thing. If you understand this one, then it should be fine. But I'm going to involve another dimensional analysis. You see, the problem is with physics. Okay, people are asking why is the mass 1 kilogram? Okay, uh, it says there the standard kilogram is a platinum iridium cylinder. Okay, meaning that platinum iridium cylinder whose density we want is a kilogram. It's just 1 kilogram. Does it make sense now? Koketso Koza and Kama Benshi, you both wanted to know why the kilogram, why is it 1 kilogram? Because it's the standard. The question says the standard kilogram is a platinum iridium cylinder, meaning that platinum iridium cylinder is 1 kilogram, one standard kilogram, just 1 kilogram. Does it make sense? I'm going to give you guys time to respond. Then I'm going to give you okay, cool. It makes sense. Now, the problem wasn't, most people would confuse and think about the problem is about density. That problem has got nothing to do with density. Okay, the problem was for you to be able to convert. Now I'm going to give a problem of my own. Okay, I'm going to give one problem. And it goes like this. And many have you seen this problem before. Okay, convert 3.5 hours. Convert 3.5 hours to seconds. Okay, convert 3.5 hours to seconds. Now, let's say you didn't know that you just divide by okay, someone got that volume. You need to cube. Chantel, you say you get a volume of 46,589.03. Okay, you need to take the value that you get at the beginning. Let me see, I think I know where you went wrong. When you were converting, did you multiply by the conversion factor 1 over 1,000 cubed? You need to multiply by 1 over 1000 cubed. And abstract vibes. If I get my answer as 214.64 multiplied by 10 to the 4, of course. Okay, remember that answer should be 10 to the 4. No, okay, no, they should be 10 to the 2 now. If you do that, if you say 214, okay, mine's worth. Some people have already worked out the answer to the problem, but I'm still in the first problem. Some people still have questions. Guys, those of you who still get a problem with the first problem, who have questions about the first problem, please. Oh yes, you need to convert your answer to the SI standard units. Okay, you always work in standard units unless they specify that they want it in other units, but you must always have your answer in standard units. That means your answer must always be in kilograms, meters, seconds, and coulombs. Okay, let me do this problem about converting 3.5 hours to seconds. Now we have 3.5 hours. Okay, we have 3.5 hours. Okay, then we do the same thing, dimensional analysis. We multiply by a conversion factor. Okay, we have hours here, so we're going to write hours at the bottom. Okay, so 1 hour is how many minutes? Okay, 1 hour is how many minutes? 60 minutes. Okay, so now our problem will be in minutes, so our answer will be in minutes. So our answer will be in minutes. Okay, so our answer will be in minutes. Let's work that out. 3.5 multiplied by 60. Let's see. 3.5 by 60, that's 60 times 3. That is 180. 180. Half of 180 is 90. So that's 270, isn't it? Let's see. Let's see if my arithmetic has failed me. 3.5 multiplied by 60. 210. Since my arithmetic has failed me. Anyway, yes, if you move the comma, you should get my answer. Yes. Okay, Avene asked if you go the other way around. Okay, I'm going to do that. Let me just finish this problem, then I'm going to go take that same problem, but I'm going to convert meters cubed to millimeters cubed. Okay, so now in millimeters, okay, so in minutes, so it's 2.10, and I'm doing it specifically this way so you can see what is happening. So I've got 210 minutes. So now it's 210 minutes, but I want it in seconds. So I multiply again by some conversion factor. I want to get rid of minutes, so I write minutes at the bottom, and I want it in seconds, so I'm going to write seconds on top. And there is 1 minute. In 1 minute there is 60 seconds. Okay, so 210 multiplied by 60. So we just multiply this by 60. So 210 multiplied by 60. The minutes here, the hours cancel, and what you're left is an answer in minutes. Here the minutes cancels, and what you're left is an hour in answer in seconds. In this case, it's 12,600 seconds. Those of you who got it correct, brilliant. So you did dimensional analysis. Okay. Lalita, you did it at the beginning. We have Mindsword who also did it at the beginning. Uh, so people, this is how you convert. This is how you do dimensional analysis. You multiply by some conversion factor. Now what you write on the bottom line is what you want to get rid of, and what you write on top is what you want your answer to be in. Okay, so let's say you want to go from meters cube to millimeters cube. It's just going to be the opposite. Let's say you want to go from meters cube to millimeters cube. Your answer is in meters cube. Okay, so you will be multiplying by you want your answer in millimeters cube. So on top is going to be millimeters, on the bottom is going to be meters, because remember you want to get rid of meters. Okay, and you're going to be squaring this whole thing, cubing the whole thing. Okay, and there is 1,000 millimeters in 1 meter. Okay, the conversion factor, and that's going to give you an answer in cubic millimeters. Okay, who asked the question? If what happens, you think it was let me see here. Avene, Mbunzima, you asked what happens if I go from meters cube to millimeters cube. Is this clear? This is what will happen if you go from meters cube to millimeters cube. The problem is a lot of you guys are going to try and memorize these formulas. You don't need to memorize them. Okay, there's absolutely no need to memorize them. Okay, everyone with me so far? Everyone with me so far? And guys, physics only works if you work at it. Everyone with me so far? Okay, so let me continue. The next problem. Uh, Mr. Chibbles number one. I say Chibbles, is it Mr. or Mrs. whatever. Uh, Not whatever. I can't see. So you saying so one will always be at the bottom? No, one will not always be at the bottom. The one that you want to get rid of will be at the bottom. Okay. In the previous case, 1,000 was at the bottom. Okay. The one that you want to get rid of will always be at the bottom. That's it. And the conversion factor, if you know that 1 meter is equal to 1,000 millimeters, I could have written here 2 meters is equal to 2,000 millimeters. Whatever conversion factor you have, that is what's going to predict what is at the bottom and what's at the top. Okay, what value, numeric value, what integer. Okay, let me continue with question number 2. And it's vitally important that you understand dimensional analysis, because from here on we're going to give you speed in kilometers per hour and want your answer in meters per second or meters per half a second, whatever. We want you to able to convert between units. Okay, you need to be able to convert between units. That is why we give you these problems. Question number 2 says an automobile company displays a model of its first car made from 9.35 kilogram of iron. To celebrate its 100th year in business, a worker will remake this model in solid gold from the original design. What mass of gold is needed to make the new model? Now the density of gold and iron are 19.3 grams per centimeter and 7.8 grams per cubic centimeter respectively. Okay, so we are given that, let's say the automobile company is Toyota. Toyota made a model of its first car in iron. Okay, so they had a toy model and it was made in iron, and it weighed, its mass was 9.35 kilograms. Okay, now they want to make this model, this exact same model. Wanda M asked why we didn't cube the minutes and hours. That is because we are not working with cubed seconds and cubed minutes. We are only working with minutes, hours, and seconds. They are not cubed. The reason why we cubed is because we went from meters cubed to millimeters cubed and vice versa. But we don't cube hours because we don't work with seconds cubed or seconds squared. Only when you're doing stuff like accelerations and stuff will you work with seconds squared. uh, Mr. Wonder M or Mrs. Wonder M, uh, did you understand now why we don't cube minutes and hours? Because we don't need to have our answer in cubed seconds. Does it make sense? We only cubed the volume because volume is a cubic unit. Volume is three-dimensional. Volume is in 3 dimensions. Time is linear, only one dimension. Does that make sense? Anyway, so we have this uh, model in iron. It has a mass of 9.35 kilograms. It's made of iron. But now it's the 100 yen business, so they want to make this model again, but they want to make it in pure gold. Okay? Solid gold. The same model, but the original design, but it's solid gold. And they want to know what mass of gold do we need. Okay? So what I would do in this problem is, first of all, you need to work out what was the volume of gold of iron used in the first when they originally made it. Okay, because we have both densities, but we only have the mass for the first one. Okay, we need to work out what was the volume of the iron. What was the volume of the original model in iron? Okay, and that's going to be have the same volume since it's the same design. It's going to have the same volume. Okay, so what was the original volume? So the original volume of the model in iron, Fe, is going to be equal to the original volume is going to be equal to its original mass in iron divided by its density, rho of iron, the iron model. So we want to work out its original volume because it's going to have the same volume when it's made in gold. So its original volume is going to be the mass it was in iron, which is 9.35 kilogram, 9.35 kilogram, and its original density is in 19.3 gram per centimeter. Now its original density is 7.87, 7.8, 7.87 grams per cubic centimeter. Now look at this. Okay, this one is in kilograms, but this one is in grams. Okay, so we need to convert 9.35 kilograms to gram. How do we do that? How do we convert from kilograms to grams? Okay, we multiply by a conversion factor. Okay, we have we want to get rid of kilograms, so we will put kilograms at the bottom. So 1 kilogram is equal to, and we want it in grams, so we're going to put 1,000 grams. 1 kilogram is equal to 1,000 grams. Okay, and we don't cube or so what we do now, that will give us the answer on top will then be converted to kilograms is going to cancel out, so we're going to get an answer in grams, which we then divide by grams per cubic centimeter, which gives us a volume in cubic centimeters. Okay, so our volume will then be in cubic centimeters. If we do the conversion, if we do the whole calculation, I'm not going to do it. I assume you are perfectly capable of plugging in something on your calculator. You should get the following in cubic centimeters. This is the volume in cubic centimeters. Okay, so now you have a volume in cubic centimeters. It is 1188.06 cubic centimeters. This was the volume of the original car when it was in made of iron. Okay, but now they want to make it a solid gold, but we need to use the same volume, but we just want to know what mass of gold do we need. So what mass of gold do we need? Gold, a U. So we want a mass of gold. In order to get the mass of gold, we need to multiply the volume of gold that we're going to need, multiply that by the density of gold. Okay, now we've already worked out the volume of gold that we're going to need is equal to 11,088 0.06 cubic centimeters of gold. We're going to need that volume of gold, and we multiply that by the density of gold, and we're going to get the mass of gold we need. And the density of gold is 19.3 grams per cubic centimeters. Okay, so the cubic centimeters are going to cancel, leaving our answer in grams. Okay, that's going to be 22.9 times 10 to the 3 grams, or it's just going to be 22.9 kilograms. 22.9 kilograms. Okay, now check this out. Our gold, our iron is 9.35 kilograms, and our gold is that we need is 22.9 kilograms. The gold has a much greater mass. Sorry, I need to move this up. The gold has a much greater mass because the gold is much denser. Okay, and mine's what everyone got the same. Okay, now the problem here is it has got nothing to do with densities and masses. It was this part of the problem here, converting from kilograms to grams. You need to be able to convert, do dimensional analysis. Okay, now we go on to problem number 3, question 3. This is one of those weird problems. A lot of students come and then they say, I don't know how to do a order of magnitude problem. The thing is, you cannot uh, practice for an order of magnitude problem because each one is different. Okay, and you need to make a whole lot of assumptions. Okay, now I'm going to do this problem. Okay, and a lot of you are not going to agree with some of the assumptions, and that is okay. But let me do this problem. The reason is why we do this type, it's estimating, it is finding the order of magnitude. It does not have an exact answer, but as long as you get close to it. Okay, because these type of answers will never be correct because it depends on you making assumptions. Okay, this one says find the order of magnitude of the number of table tennis balls that will fit into a typical size room. Uh, you didn't understand what? Semolemo. You say you don't understand, you're going to have to be specific. What is it that you don't understand? How to convert from kilograms to grams? Or are you talking about order of magnitude questions? These problems are going to be very difficult, but well, not difficult, they're not difficult, you just need to make assumptions. And everyone's assumptions are going to be different. Even right now, I'm not going to have these same assumptions that you might make. Okay, well, you tell me specifically what it is that you don't understand. I'm going to continue with question number 3 as we only have 10 minutes left. Uh, and I'm not going to rush. If I don't finish, I don't finish. Okay, let's see. They say find the order of magnitude of the number of table tennis balls. Okay, so ping pong balls. Okay, that would fit into a typical sized room. So the question is basically asking how many table tennis balls would I be able to fit in an average sized room? Now, here's the problem with this question that all of you will immediately have a problem with is what is the size of an average size room? What is a typical sized room? Okay, what is the volume of a typical sized room? Okay, so how big is a typical sized room? Okay, for me, a typical sized room would be, say, 4.5 by 6 by 2.5. For you, it might be 6 by 6 by 6. There is no such thing as a typical sized room. Okay, it is just this is why these problems order of magnitude problems. Remember, mine's what if that is your typical sized room, then you also need a height. Now this problem just wants to know how many balls would I, how many, more or less, how many balls would I be able to fit in a typical sized room? Not just any balls, table tennis balls or ping pong balls, as they are also known. Okay, so first of all, let's calculate, say, the volume of an average room. Number one, let's calculate the volume of a typical room. Okay, so let's calculate the volume of a typical room. Now this is going to be different from yours. Okay, this is going to be different from yours. I would say that the average volume of a typical room, it's well, the room would be cubed, so it will going to be length times breadth times height. Okay, so let's say the length is about 4.5 meters. They need a value, yes. An order of magnitude means they need a value. Okay. So let's say a typical room for me would be 3.5 meters. Would that be enough? 3.5. Let's say 3.5. 3.5 meters. The breadth of that room would be 6 meters. Let's say 6 meters. Now this is an order of magnitude calculator, meaning it's an estimate. Now the height. What is the height of a typical room? 2.5 meters. Uh, Average size person is about 2 meters. It's slightly above that, so let's say 2.5 meters. This is a typical room. Now, guys, this is my assumptions. Okay, these are my assumptions. If you were to measure your own room right now, it will most likely be different. Okay, this is a typical sized room that I just plucked out of my head. Okay, so 3.5 times 6 times 2.5, that should give me a volume around 67.5 cubic meters. That's 67.5 cubic meters. So this is the volume of a typical room. Now we need to work out the volume of a ping pong ball. Okay, so the volume of a ping pong ball. So the volume of a ping pong or table tennis ball. And I know a lot of you are going to say, repeat this question, you don't understand. As long as you understand what I'm doing now, then you should be fine. Okay, so they want to know how many balls can fit into an average sized room. Okay, so you have an average sized room. Did I do my calculations wrong? Because Latita, you're saying it's 52.5. Let me see. Oh, is it 52.5? Let's see. 3.5. Oh yeah, I had previous assumptions. Sorry, this is my previous assumptions where I changed this one. Sorry, I changed this one to 4.5 to make it more realistic. Sorry, guys. Then it should be correct. I previously had 3.5, but then I realized that is a bit too small for a room, so I changed it to 4.5. That's more or less an average room. I added a meter. Sorry, that's why it's that. Okay, so this is like the size of a typical room. Okay, now we need like the volume of a ping pong ball or table tennis ball. Okay, now this I actually had to go and look up. Okay, the volume of a of a sphere is pi, the diameter cubed over 6. This is the volume, the formula for a volume of a sphere. Okay, remember this is not radius, this is diameter. Okay, so pi, and I actually had to go look up the dimensions of a ping pong ball or table tennis ball, and it is approximately 0.038 meters in diameter, cubed over 6, giving me the volume of a ping pong ball of about 2.87 times 10 to the negative 5 cubic meters. Okay, so the first one I had to make some assumptions about the size of a room, and then I actually had to go look up for a table tennis ball. Remember, if they were to ask you this in an exam, they're going to have to give you this volume of a, or assuming those assumptions, you're going to have to make certain assumptions. Okay, so I have the volume of a ping pong ball. I have the volume of the room. They want to know how many balls can I fit into a typical size room. So we have the volume of a typical size room. We have the volume of a average ping pong ball. So the volume, the number of balls that can fit into a room is going to be the volume of the room divided by the volume of a single ball. So the volume of the room is 67.5 cubic meters, and the volume of a, so the number of balls that can fit into a room is going to be the volume of the room divided by the volume of a typical ball. So and that is 2.87 times 10 to the negative 5 cubic meters. Okay? Now cubic meters cancels out, so the answer is going to be a dimensionless quantity. And I worked it out to be approximately 2 times 10 to the 6 balls. Okay, so this is approximately how many balls there will be. About 2 million balls will fit, about 2 million ping pong balls will fit into an average sized room. Now this is assuming that there is no furniture in this room, and assuming that this room has uh, those exact dimensions. Okay, William writes asked a question that I have asked myself every single year. Okay, Cello Calvin. Actually, I'm not going that fast. I first worked out just the volume of a typical room. So I just a typical room volume, and then I just worked out the volume of a ping pong ball. Okay, because I want to work out how many balls approximately would fit in a typical room. So first I had to calculate a typical room, the volume of a typical room, 4.5 multiplied by 6 multiplied by 2.5, which gave me 67.5. Okay, and then I had to work out the volume of a table tennis ball, and this is how you work out the volume of a table tennis. It's pi, the diameter cubed over 6. Now this diameter I just had to go look up. Okay, it's 38 millimeters, and then you get this volume. So now you have the volume of the whole room and the volume of a single ball. Okay, now to get the amount of balls that can fit into a room, you need to multiply the diameter, you need to divide the volume of the room by the volume of a single ball. Mr. Cello Calvin, or Mrs., does that make sense? Does it make sense now if I explain it when I had that brief recap? Do you understand now? While you are answering, William writes, you asking, okay, so if this question is based on assumption, how sure are we that some's answer is wrong because everyone has different perception? That's the problem with these questions. Okay, there is not going, if you may, there is not going to be actually a wrong answer. Okay, because because everything is based in order of magnitude questions like this particular one. There is not going to be a wrong answer because it depends on what you choose originally. Okay, what you choose. If a typical room size for you is 2 by 2 by 2, then your answer is going to have to be the answer that you get because that is a typical room size for you. Okay, in order for these questions to be valid, they're going to have to put restraints on saying that the room must be this size, the room must be between this and this length, and it must be between this and this, so you can get like kind of a limit. But without a limit as to your assumptions, without limits to your assumptions, this this question is going to spiral out of control. Okay, but as long as you understand what I did, okay, and there is no way of actually preparing yourself for order of magnitude question because each one is different. Like look at question number 4 exactly. Okay, Wanda M, you asking that, which means the answer for this question is always 10 to the 6. That is both yes and no, because The answer is going to be yes. It's always going to be times 10 to the 6. Né? If the volume of the room is close to 67.5 cubic millimeters. But if the volume of the room is larger, then it's going to be probably bigger. Or if the volume of the room is smaller, it might be less balls. Okay? So let's go to question number 4. This is why I hate these. Well, not hate them. I don't like them because they are based on assumptions, and everyone is going to have a different assumption. Meaning, everyone will have a different answer, which must be correct because everyone made a different assumption. Now, this is another one of these order of magnitude questions. Okay. It says here, assume. Okay, compute the order of magnitude. And guys, I think it's 4 o'clock. So let me just do this one, and then the next one I'm going to ask Arnold to do. Can you... Let's assume, okay, it says compute the order of magnitude for a mass of a bathtub half full of water. Okay, so we need to work out the mass of a bathtub half full of water. Okay, so now we need to make assumptions about the size of the bath now. See? So let's say for A, let's call it question 4.1. Okay, let's assume that this bath has dimensions of 1.3 meters in length, half a meter in width. This is assumptions, okay? These are all assumptions, and about zero point 0.3 meters in height, okay? So this is the volume of the tub, this bathtub. That will give you, and we want it for about half, okay? We want the mass of half a bathtub of water. So multiply it by a half. That gives us about 0.1 cubic meters. So about zero point 0.1 cubic meters of water is in a bathtub of these dimensions. Okay, all you need to work out is about the volume of half a tub of water if you give the dimensions yourself. Okay, now the mass of the water, okay, you need to work out the mass of the water. It's going to be equal, we have the volume, so the mass is going to be the density of water multiplied by the volume of water. So the density of water is 1,000 kilogram per cubic meter, and the volume of water we just worked out to be about 0.1 cubic meter. 0.1 cubic meter. So about 100 kilograms. Okay. So half a bathtub of water is about the weight of the mass of half a bathtub of water is about 100 kilograms. Okay. Now it's going to be different for everybody because everyone is not going to pick the same dimensions for a bathtub. Okay. Your bathtub might be bigger, yours might be smaller, as long as you understand what we are doing. Now they're saying compute the order of magnitude of the mass of the bathtub half full of copper coins. Okay. So all you need to do now, you already know that you already have the volume of half a bathtub, okay, and here you use the density of water, but they're saying what if we were to replace the water with copper coins. Okay, so you need to now calculate number 2, the mass of copper coins. Okay, if the so you're going to need the density of copper coins and the volume of copper coins. But the volume of copper coins is the same half a bathtub. Okay, so the volume is going to be the same 0.10 cubic meters, but the density of copper, by the way, copper coins is also an alloy. It's not just made out of pure copper, it is alloyed with another metal. So a lot of assumptions are made, but the density of copper is about 8,920 kilograms per cubic meters. And if you work it out, it comes out to 892 kilograms. So about 892, and that is approximately 1,000 kilograms. So the mass of half a bathtub of water is about 100 kilograms, and the mass of a, a half a bathtub of copper coins is about 1,000 kilograms. Okay. Now, guys, I know that these problems. Okay, where does the density of 1,000 kilograms per cubic meter? That is the standard density of water, Mr. Koza or Mrs. Koza. If you look at any table or online, the density of water is at 1,000 kilograms per cubic meters. That is problem number 4. Problem number 5. Let me just do it quickly so I don't have to do it with Arnold. Let me do that problem quickly. Then you don't have to do it with Arnold. I think it's Arnold or Dr. Jenna tomorrow. Okay, so this problem says, problem number 5. A person walks 25 degrees north of east. Okay, so here we have a person. We have this. This is east this way, and this is north. Okay, so a person works 25 degrees north of east. Okay, so this person is working 25 degrees north of east. Okay, so this line is going somewhere there, and this person is going north of east. Okay, so 25 degrees north of east. Okay, and that person walks 3.1 kilometers. Okay, so north of east means you go to east and you move your pen 25 degrees in a northerly direction. If it was south of east, it would have moved this way. Okay, so this is north of east. Okay, this person works 25 degrees north of east for 310 kilometers. How far would she have to walk due north and due east? Okay, so basically what they're asking is to break this thing down into its components, into its vector components. Okay, using 25 degrees and that. So you have 3 point, that is the hypotenuse, that is the northerly direction, and that's the easterly direction. Now to get how far she has to walk north, all you have to do is, north is going to be the sine of 25 degrees. The sine of 25, this is basic trigonometry from high school. The sine of 25 degrees is going to be the distance you have to walk north over the hypotenuse of 3.1 kilometers, and that is going to give you, you have to travel north a distance of 1.31 kilometers. Okay, I'm not going to do the whole question. And then the same thing for east is, you're going to work the cosine of 25 degrees is equal to the distance she has to travel east over 3.10 kilometers. And if you work it out, you should get that the distance she has to travel east, or this person has to travel east, is 2.81 kilometers. Okay, now guys, this is all that we have time for today. I hope you enjoyed your first session, and that tomorrow things are going to go much smoothly. We've sorted out some of the bugs, the kinks. Now tomorrow you can come with answers for James or whatever, and then you can go and work on all of these problems. Okay, I will see you next week Tuesday. All of the best and have a good week. Bye, guys. And if you want to watch the video, it will be on YouTube.